everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the actual implementation of Text to SQL. This will be a part 1 video of the entire implementation. The entire implementation, if I cover in one video, it will be so long and boring. So that is why let's make two parts of the video. So in this particular part, we'll be looking into the initial steps of what has been done in this particular project. So initially, we'll be simply importing certain libraries which are required for this particular project. So in here, I have imported my SQL.connector for because of which we'll be connecting our code. I mean the code base with the MySQL database so that we can simply fetch the data from there. We can connect with the database. We can execute the query on the database and get the results in here. So like that. And so for that purpose we'll be using it, and these are some simple libraries which are prerequisites. Then we'll be using langchain as a wrapper for calling out the LLM. So here we'll be using specifically langchain underscore grok. From that we'll be using the chat grok module because we are going to use a large language model from the grok provider, and because of which we'll be using this particular wrapper. And then we'll be using certain langchain fundamentals, like for example prompts, the chat prompt template, messages, human message and AI message, then the output parser for getting a structured output. That's it. Next we'll be importing some imports from langgraph. So basically, as I said already, that we are going to build this particular entire workflow in langgraph framework. So it will be a better practice for, because it's a better practice for any GenAI application to be developed in a framework, an agentic framework. May it be LangGraph, may it be Crew AI, or so on. So here I am specifically choosing the LangGraph, from which we are going to use the state graph for building the graph and start for starting and ending the nodes. Next, we'll be also using the graph messages like add message so that we could use it in our state definition. Next, we'll be using the check pointer memory, that is the memory saver, so that we will be having a track of every single session, whatever is there, and that too based on the configuration ID. Based on the configuration ID, we'll be having separate list of tracks, or I would say messages. So because of which we'll be using these three things. Next, we'll be using some imports from Ragas to evaluate. So basically from Ragas we are going to import evaluate, answer relevancy, faithfulness, dataset, from which we are going to use some of them. These things will be useful for our Ragas part, for the evaluation part, for checking out the answer accuracy. Next are some utility imports, and that's it. So these are all the imports. Now with this we'll also set our configurations. So now basically here we'll have to set up two configurations, one for the LLM and second for the MySQL. We have to connect our code to the LLM, I mean the Grok provider. So for that we'll be using Grok API key. You can simply create your Grok API key from the Grok website. If you don't know how to create it, already I have covered it in my previous videos in the GenAI playlist, so you can just have an overview of it. Once we set our Grok API key, we'll set it in our environment as an environment variable. Next, we'll be configuring our MySQL config. So over here, you can see in the config, I have set host, user, password, database, and the port. So over here, if your MySQL instance is hosted on some particular URL, then you can simply write your URL in here. If it is in your localhost, then you can write localhost. Your username and password, it totally depends on how you configure it in the database. Then you have the database name in which your tables are situated, and this database name is the only database which you are going to interact with. Okay, you can have an access of multiple tables, but the database remains the same. So let me show you this particular connections over here. You can see this third connection that I have made for text to SQL. Its username is root1, and if I click this, you can see the connection has got established in here, and I can see all the tables and all schema, everything in here. I have this query executor also. So this is the only thing that we want to access, right? All the tables and all. So for that we are going to use this particular set of parameters for establishing the connection with MySQL. Over here, if you want some other database to be connected, like for example the PostgreSQL or the SQLite, then you can simply put your configurations in the manner in which they follow. So you can just have an overview of the documentation of SQLite or PostgreSQL and get this altered. Next we'll be configuring, next we'll be initializing our LLM object through the chatgrok wrapper. So over here inside this we'll have to pass on the model name. Specifically over here I'm going to use OpenAI's GPT OSS 20 billion parameter model, which is open source model, and since it is present on Grok I'm using it. If you want to use some other models which are present on Grok, you can simply browse their website and you can see the list of models that are available on their website. You can use that. Next, we are setting the temperature as 0 because we want our query that is going to be generated, the SQL query, has to be exactly precise. We don't want any kind of variations or hallucinations in that. So I don't want any risk in that. So that is why I'm keeping the temperature as 0. We'll set some max tokens and the Grok API key. So with this, your LLM will get initialized, and then if you want to test it, let me just execute these cells and let's check whether our LLM is actually initiated or not. So you can see I'm invoking the LLM with the hello world message. Let's see whether the response comes. Yes, a response from the LLM has got come. It means that our LLM has got initialized successfully. Now the next thing that we are going to do is we'll be defining our database manager. So basically this is nothing but a class. In this class we'll be defining all the functionalities which are related to our database. May it be connecting with the database, may it be getting the schema of the database, may it be executing the query of the in the database. So basically you can define, so here I have defined a database manager class which is initialized with this particular constructor. Here this particular class will be getting a config and it will get configured so that the connection will get established. So we have defined three variables: config, connection, and schema text. So basically this config the user will be passing. The connection is initialized to none. It will get dynamically updated whenever the connection gets established. Then the schema text, which is now an empty string. So over here you can see we have this particular MySQL config which we have already defined earlier. All these things as a dictionary will be passed on to this particular database manager and it will be stored in the config self.config. Now we'll be defining a connect function which will be doing the task of connecting our code to the MySQL instance. Here you can see I have also ensured best practices of coding using the try except thing, so that whenever any error comes it will get handled. So over here you can see self.connection equals MySQL connector dot connect. The config that we have got from this particular dictionary, that will be same passed into this particular connect function. So our connection will get established and the connection object will be created. And if it is successful, we'll return true. Otherwise, we'll print that there is some connection error with the error message and will return false. And unless the connection is made, no further processing can be done. So that is why this is the very first step that has to be passed, that has to be successfully passed. Next, we'll define a get schema function. Now why this get schema function is defined is because whenever the user puts a natural language query from the UI, that natural language query will be obviously be related to a table which is present inside the database that is currently in use. It can be related to one table or multiple table. So whenever from that natural language query a SQL query has to be generated, while generating the SQL query we need to make sure that the LLM who is going to generate that particular SQL query should have the information about the schema definitions of the entire database which is currently in use, that we will be providing in the prompt. So that getting the schema as a string, we will be using this particular functionality, like what all tables are there, what are the features of the table, data types and everything, we'll be storing it in this particular schema. Here in this particular function it will be only be applicable whenever there is a connection which is currently present, otherwise it will not happen. So this cursor will specifically be used in execution of the queries. So what we'll do is we want the schema, right? We want the information about every single table. So for that we'll use cursor.execute show tables. Now this show table will give a list of all the tables along with its schema information. So So inside the tables variable, will be storing that particular result, cursor dot fetch all. Now we'll be defining a schema text. As you know that LLMs only take text as an input. No object can be given. So that is why here we'll be defining a schema underscore text variable, which will be containing the updated information about the current schema of the tables. So we have got the tables information in the tables object, and inside the schema text variable we'll be updating the information as table colon the table name. Next, if you want to get the columns of this particular table which is currently in under control, so over here cursor dot execute. See, we are executing describe command in this particular section. So if we do describe table name, then we get the information about the table name. Let me show you how this works. So as you can see here in the MySQL, I have a table named students. So if I want the information about the students table, I simply have to execute this describe space the name of the table. If I execute this, I'll get the information about the students table. So over here you can see we have got the information. This contains the field, student ID, first name, last name, email, and all those things. The type of it is also defined, extra information like whether there is a null value present or not, primary key and all those stuffs, everything can be listed from here. So the same thing has been done in here. To get the information about every single table, we'll be using this describe and then the table name. So once we get this, we'll be getting all the column names and everything. So we'll now update the schema text variable. As shown, we get 5 different things, that is the column name, the column type, nullable, key, and the default or extra. 5 to 6 different things we get. So inside the schema text variable, we'll be updating every single thing in here. So first we get the table name, then we get the columns list, the column name, the column type, and then we'll also provide an information about the key, which column is a primary key. So like this, we'll be updating the schema. And it is also recommended that not only the column information or the table information, but it sh- but it is always a better practice to include some samples inside the prompt. Whenever you give information about a table, it's always better to include sample information also, like how, like 1 or 2 rows or maybe 5 rows, depending upon the complexity of the table that is present. If the table is too lengthy, you can simply pass on only one single sample row. If it is not that too lengthy, then you can use 2 or 3 rows at a time. So here you can see I have executed this select star from the table name which is already in use, and then limit 2. So this will give us only 2 samples data, the first 2 rows of this particular table, and then we'll jot that particular sample inside the schema text. It's very simple. I'll just show you one example how our schema text will look like once we execute this. Then we'll close the cursor and then we'll return the schema text variable. So let's just execute this. We already have the object DB of the database manager. Inside that, we have already passed on the config which was earlier defined above. And then once this is done, we'll now quickly print the database.schema. So let's do that. So yes, the database schema has got printed. Over here you can see the database schema. For every single table it goes on. So like for the courses table, we have all these columns with its primary key information and all those things. Then also we have the sample rows. You can see only the first 2 rows has got sampled here. Similarly, next there is another table that is designation, its columns and everything is there. So this particular information will be every time passed on to the LLM whenever a SQL has to be generated. If you don't pass these things, the SQL that is going to be generated, it will be hallucinated response, because LLM doesn't have the information about what your table looks like, right? So how the LLM will give you a correct response? So for that, we'll have to pass on these things as an input to the LLM while generating the SQL. Now I hope you understand this particular function, the usage of this particular function get schema. Next, we have the execute query function, which is the most important one, because whenever your SQL get generated from the previous stage from the LLM, whatever SQL query comes out, we will have to execute that particular SQL query to fetch the results from the database. Now, for execution of the SQL query, it is not obviously executed in the Python code, right? We'll have to connect our database, and there, with the help of the cursor, we'll have to execute the query that is generated. So here you can see we have this particular function execute query, which will take in a parameter query. And then what we'll do is we'll establish a cursor connection, self.connection.cursor. We will do cursor.execute query. That's it. This simple one line will execute our SQL query that was generated, and the results will be stored inside the cursor object itself. And then we'll simply execute the query, and then once the execution of the query is done, we'll simply format and return the results. So over here you can see we are returning a boolean value that is true, that the query has got executed successfully. Next, the results variable in which we have stored all the results, and then the columns which are actually a part of this particular query. So all these things will be returned, and this is what is the use of this particular function execute query. Next, as I already said, we will be defining an object of the database manager class with the MySQL config which we have earlier defined, and that's it. Now there would be one question in your mind, that if there is some queries, I mean some dangerous queries, like for example alter, drop, delete, then for all such commands will our pipeline allow it to execute or not? See, this totally depends on your use case. For any text to SQL use case which is used by used by multiple users who are technical or non-technical, then in that case it is always a better practice to restrict all these commands like drop, delete, truncate, because executing this particular command will simply flush out every single records from your database. So for that we'll be applying a filter on top of this particular function. So in this particular project, I have used that particular filter. Like whenever we address certain query commands like truncate, delete, drop, then in that case it won't execute that particular query. It will simply throw out that and stop the execution. So that part of logic we are going to define it inside the nodes of the LangGraph flow. So that particular part where this particular logics will be applied, we will be looking it into when we'll be building the nodes of the LangGraph. So in the next video, we'll be discussing about how we can define the LangGraph flow. In that, I'll be showing you every single step of how nodes can be defined with the help of LangGraph. Every single step by step node definition, the edges definition will be defining, and will compile the entire flow, and then in the next video only I'll show you the entire execution of this particular code. So I hope this particular video, the part 1 of this particular text to SQL project, is clear to you all, and I hope you guys must have understood every single functionality that we have developed here till now. I hope everything seems to be easy. If you have any single doubt, then you can simply straight away put it in the comment section. I'll be happy to solve it. Also, if you have any suggestions regarding this particular project or any other projects in generative AI, then you can simply drop it in the comment section. I'll surely reply you with. Stay tuned for the next part. If you like this particular video, please do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.